Good afternoon, students. Have you settled down? Can somebody there listen to me and answer if everybody has settled in the classroom or not? Hello.
Yes, ma'am. Can you hear me, ma'am?
No, what is the problem? Okay, right? I have started. I have unmuted. And the video is there. That's how you have to respond. You have to provide.
Ma'am, you are in mute, ma'am.
Okay, now can everybody hear me?
Yes, ma'am.
Okay, but the camera angle at the center is not is placed in such a way that I cannot see any student there. Can it be? Can there be something which can be? Can something be there? Yeah, it's better now. So, good afternoon, students. Can we start the class now?
Yes, ma'am.
Okay, good. So this was the last, see, I think we are meeting after 15 days, right? Can any one of you apprise me or tell me what is being taught to you in your school? What are the chapters which you have finished till now? See, only one, I cannot hear and understand everybody.
For A section, chapter 1 gonna complete, ma'am, but for B section, completed, ma'am.
Okay, in chapter 1, is anybody having any basic concepts which you do not understand? Again, I'll appreciate only one student to answer me.
Molality, ma'am.
Huh?
Molarity and molality, both.
Okay, mole concept is clear to all of you.
Yes, ma'am.
Okay. See, today I will be first of all quickly recapping the whatever you might have learned in the classroom. So you can always tell me, ma'am, this is completely clear. The reason being that at times we are here to understand the class 12 as well as the foundation chemistry course. At times the questions are of a very basic level and which we miss as a class 11 student. as they are not expected to be asked in the examination. So if you feel the pace of the class is less, I'll make sure that after your feedback or once you tell me, I'll be able to increase that, right? So this was the question which can be seen on your screen. What is the answer to this question and why? Do you
Chopped
remember in the,
potato, ma'am.
huh?
Chopped potato, ma'am. Can you hear me, ma'am?
Yeah, I can hear you, but I cannot understand what are you saying. Can you just repeat it bit again? I'll appreciate if any one of you can answer me. I believe somebody said diced potato. Dear students, please, one of you, please come up with the answer.
Diced potato, ma'am.
Diced potato. But why? The answer is surface area. Assuming it to be a whole potato, if I put it in smaller parts, then the areas at which the water molecule can act increases. Earlier, the surface area was less. Now, when you cut it, the surface area increases. That is the reason we cut all the vegetables or fruits or the protein diets like fish and mutton before we cook them. Is it clear? Now coming back to quickly to what we have in the chapter 1 for us. This is the entire syllabus which we will be covering for chapter 1, right? Now tell me, I do not find molarity and molality written here, right? But before that, we need to quickly go through these concepts. They are in syllabus also. So can somebody classify definition of matter? I believe everybody knows. Now, can somebody classify matter for me?
Ma'am, which occupies space, ma'am.
I'm asking for classification. Definition wise, I will say, I will just believe since it's a class 9th ninth concept. Definition wise, we say that everything matter has mass and it occupies space.
Yes, ma'am.
Tell me, shadow. You must be familiar with shadow. You must have seen your own shadow or shadow of a tall tree. Is shadow a matter or not? See, we all of us know that what is matter. If you have any doubt in it, do ask me. Else answer the question. What is shadow? Is it matter or not? So I'll appreciate your participation and your answer. See, if you keep your answers with yourself, I may not be able to correct you, right? So just make my job easier by telling me whatever you think about shadow. Is it matter or it is not matter?
No, ma'am.
Why? See, whenever you answer in the class, I'll appreciate if you can give me the reason also.
Because it doesn't occupy space.
It does not have mass, more importantly.
Mass.
Yeah, it does not have mass. Some people may say that when you are seeing it, it may be looking like that it is occupying space, but definitely it does not. Even otherwise, what we have to do, understand it, that if it does not have mass, it will not occupy space, and therefore shadow is not a form of matter. What about the feeling of, let's say, hatred? Quickly, that's a basic question. So I'll tell you, feelings do not have, neither they have mass nor they occupy space, right? Therefore, they are classified as, they are not matters. But if I talk about the smell of food, maybe your favorite food can be pizza or the rasam at home. What do you think about it? Any idea? A good smell or a bad smell, what it should be? Anyone, please speak whatever you have to. I didn't get you. Can you please repeat it? Sir, please give a speaker to the students. Okay, since we may be losing some time, I'm just answering your question. The question is, smell is also considered as, it is not matter, but at times it makes me feel that this smell is coming out from a matter, but it is itself is not a matter, right? It must be made up of particles. Only then it reaches you, isn't it? So to me, and if you study in a higher ranks, smell is a debatable issue, right? But for answering a multiple choice question, we say smell is not matter, right? Making sense to all of you? Is there any problem in the classroom?
It's not working.
See, students, I can feel that you are discussing something, but what I'm not able to hear.
Mic is not working, ma'am.
Okay, then how we are going to communicate in the class then?
They're getting it ready, ma'am. 5 minutes, it'll take 5 minutes at least.
Okay, let us then, that can we proceed without mic? Is the part of smell is clear? Just say yes or no, so that I can move ahead with the class. There is no point in waiting for it.
We'll show thumbs up for us, ma'am.
You have queries, so please ask.
Ma'am?
If it is okay or else we'll show thumbs up, ma'am.
I didn't understand.
If it is yes, sir, we'll show thumbs up, ma'am.
Maybe louder. Make it louder.
If it is yes or we'll show thumbs up, ma'am.
See, I have told you that matter has mass and it has a space. Then we have done few things. We have understood shadow is not matter, smell is also not matter. But logically thinking, smell can be matter because it is the particles of food which are producing smell. It's not food particle. Some people believe that food particles reach us. They do not reach us. The aroma which is coming from them is reaching us. So never be confused, because I have referred few books which believe that smell is form of a matter. But the correct answer is that smell is not matter. Is it clear? Just say yes or no so that I can proceed further.
Yes, ma'am.
Okay, good. So I am sure we are just moving ahead. This type of a classification of matter, you must be aware of that matter can be classified either into solid, liquid, or gas, or it can be classified into element, compound, and mixture. Not going into details of it, but I really want to know what is the basis of this classification. The first type and the second type. That type of a question can be asked. That what are the, like your books, your copies can be classified on various bases. That is, you can put them subject wise, right? You can arrange them in the increasing or the decreasing order of the size. But here on the screen, I am showing you two classifications of matter. Now, can anybody tell me what are the basis of the, what is the basis of the first classification and what is the basis of the second classification?
Can you repeat the question, ma'am?
On the screen, you can see two classifications of matter. First one is that solid liquid matter can be classified into solid state, liquid state, or gaseous state, or simply solid, liquid, or gas. Another way of classifying matter is that you can classify into element, compound, and mixture, right? We understand that every classification has a particular basis. What is the basis of this classification? The first one and the second one.
Just like a chemical composition for the second classification. And the physical state was first one.
Okay, that was not the precise answer. See, when you're solving MCQ, they never say, if you read the headline, it is written as choose the most appropriate answer, choose the most correct answer. They never say rest of the answers are incorrect. So if you have known the solid, liquid, and gaseous state closely, you will be knowing that states of matter, or as you said, that is partly correct, that can be considered as a physical classification of matter. But my question was not that. My question was, what is the basis of this classification? The answer which I was looking was arrangement of atoms. Arrangement of atoms or molecules in it, because we have read the properties of solid, liquid, and gas very thoroughly, that in solids, the atoms are very closely held together. In liquid state, they are a bit far off. And in the gaseous state, did you want to say anything?
Yes, ma'am. Can you be a bit louder, ma'am? Someone say that they can't hear you properly.
Okay. Now, is my voice more audible to all of you?
Okay, ma'am. Yes, go ahead, ma'am.
Okay. See, I was saying that the states of matter is considered as someone of you. I'll appreciate if you can first of all tell me your name so that it becomes easier for me to recognize, right? As we say that states of matter is a physical classification of matter, and the basis of it is arrangement of atoms and molecules. That is the most correct answer. If you have to make a choice between physical classification and arrangement of atoms or the constituent particles, the arrangement of atoms or molecules will be the more appropriate answer, right? So when we are studying, I prefer to tell you how to answer any question. There can be a choice of elimination that out of four, one becomes the obvious choice. Other time, the options are very closely associated with each other, right? So in that case, what should be the best answer? In this case, the best answer will be arrangement of atoms, right? Now, the second one, for which we call it as a chemical classification. What is its basis? It is based on types of atoms. As you know, element will have only one type of atom. Compound will have one or more than one type of atom of different type. Whereas in mixture, the atoms or the compounds or the constituents will be arranged or will be kept in or mixed in any ratio. Is it clear that what is the basis of physical classification of matter and the chemical classification of matter?
Yes, ma'am. It's clear.
Okay. Now, this is the difference between the physical and chemical, different states of matter. That solid has many surfaces. Do you know what does that mean? This point I have just highlighted because I know rest of them they must be on your tips as of now. What do we say that solids have many faces? Do you understand this?
No, ma'am. Actually, we are not sure what is it.
Okay. You have your copies with you, right? I have my mobile with me as of now. Can you see how many surfaces does it have? One surface is here. This is another surface, right? This can be considered, this is another surface. You might have played the game Ludo. Where you see 6 surfaces are there. Do you understand the meaning of surface now?
Yes, ma'am.
Okay. So that is the one of the points. I will not repeat rest of them. If you have any doubt in them, then please ask me. Now, talking about the liquids. If you look at the liquid, this is a glass of water, it's an empty glass with me. Now I am pouring some water into it, right? Now, how many surfaces can you see into it? I didn't hear you clearly. Can you be a bit louder?
Two, sir.
Liquids will always have one surface. You can see this one. This is the only surface. You pour any liquid, a pure liquid. Pure liquid means don't pour the the curry of your vegetables, because they will have a vegetable pieces also. Any clear liquid will have only one surface, right? This is here. And then what about the gases? You might have played football, you might have used balloon, and in the room where you are sitting, what is there? It is filled with air. Air is a gas, or the components of gases of the air are gases. You may say it has some dust particles also, but we will leave it for the time being because it is in a very minute quantity. We cannot see air. That means the gases do not have any free surface. So this is what we must understand as a class 11th student preparing for any competitive exam. Rest of the things are clear to you, right? When we said liquids do flow, gases do flow, but there's a difference in the flow of liquids and the gases that we understand. Similarly, for liquids, if I have written cannot be compressed, that is by and large, right? Some of the liquids can be compressed, and they can be compressed to an extent, if at all they can be, right? So is there any doubt in the physical classification of matter? I have taught you one new thing, that's all.
No, ma'am.
Okay, thank you. See, if I have some sugar, again, this was a question. I have some sugar, I'm pouring it in a glass bowl, right? What can you see here? What is formed? What is this particular thing called as? Which makes liquids different from solids or gases. Sorry, which distinguishes solids from liquids and gases. What can you see here? If it is not clearly visible through camera to you, I will just tell you that whenever you pour a solid, you can do it at your home like I was doing here. Take half kg or 1 kg of a sugar, take a flat surface, pour it there. They form heap, H-E-A-P, heap. That is a distinguishing character of solids. Liquid never form a heap, nor gases, right? So the formation of heap is a characteristic of solids. Making sense? Okay. If you are asking a question, I'm not able to hear you. If you are saying yes, I'll proceed
Yes,
further.
ma'am.
Okay. Now coming to the laws of chemical combination. Do you know all the laws which are listed here on the screen? Someone from the class should take a mic and answer me so that I can quickly leave certain laws and then move to the next ones.
Yes, ma'am.
You know every law?
No,
Okay,
ma'am, we are-
these are the part, okay. Should I teach them in detail or should I teach them quickly?
no, ma'am, we have already been taught these, no, but we would like an intro.
Okay,
First,
okay,
glance.
I will. Okay, whenever you want me to increase or decrease the pace of the class, do let me know. I have listed
Yes, ma'am.
down the laws of chemical combination. And again, as I said, for the rest of the part of the chapter, I will tell you something which is not there written in your CBSE book. It's +1 as per your requirement. So the three laws, law of conservation of mass, definite proportion, and multiple proportion, they deal with the mass relationships. Whereas Gay-Lussac's law of combining volume or gaseous law of Gay-Lussac's law of gaseous volume it deals with the volume of reacting gases, right? Then moving on quickly to law of conservation of mass, that means mass can neither be created nor be destroyed. This was an old definition. It applies to most of the chemicals and most of the reactions. Can anybody tell me the exception to law of conservation of mass? An example of a chemical reaction where mass is not conserved. I show you this example, that if I have taken 100 grams of mercuric oxide, I'm heating it, then what I'm getting, 92.61 grams of mercury, 7.31 grams of oxygen. Total mass of reactants and products is equal, right? Therefore, it is obeying the law of conservation of mass. Any exception to this law? Okay, have you heard about the ongoing Russia war? Russia-Ukraine war?
Yes, ma'am.
They are using bombs, right? And then bombs are being used since long time. The famous Hiroshima, Nagasaki bomb blast. What is the source of that energy which
Nuclear
destroys? Nuclear energy, very correct. And similarly, the source of energy of sun is nuclear energy. There are two types of chemical reactions which are not part of, which do not follow this particular law. We call them as nuclear fission and nuclear fusion. Can somebody tell me the meaning of fission and fusion? At least fission, I believe you can tell me. All of you are just freshly passed from class 12.
Breaking of atoms. Breaking of atoms to produce energy.
The fission and fusion, fission means breakdown.
Yes, ma'am.
Breakdown, I was expecting the answer because you have binary fission, multiple fission in biology section of science of class 10. Nuclear fission means that uranium, let's say a big molecule, big atom rather, atom of uranium is broken down when it is bombarded with neutrons. I'll write it somewhere else. When uranium is bombarded with neutrons, what happens? It breaks down into a smaller atom of, let's say, barium, krypton, and along with lots of, or we can put it as huge amount of energy. Similarly, if I talk about nuclear fusion, fusion means union. So during nuclear fusion, what happens is that this type of a reaction happens at the surface of sun, I will say. That two atoms, the smaller atoms, remember here, when you have to break, you have to have a larger atom which can be broken down into smaller parts. When you are fusing them, then you are bound to have smaller atoms. So what happens here is atoms of hydrogen, right? They combine to give you helium, right? And again, large amount of energy or huge amount of energy is given out. Now this energy, from where this energy comes? There is a formula, Einstein formula, we say it as Einstein or Einstein, whatever you want to say, E is equal to mc square. Have you heard about it? The Einstein
Yes,
formula.
ma'am.
Yes or no?
Yes, ma'am.
Okay. What happens here is that some mass which is present in the atoms is converted into energy. And this energy is humongous. It can destroy the entire human population. So in this reaction, law of conservation is not obeyed, right? But remember, nuclear reactions are rare. Like Ukraine war is a rarity, although it is continuing for years now. Same thing goes for Afghanistan, I believe. Nowadays, I have heard there is a riots going on in Paris also. So whenever you hear about nuclear reaction in the form of bombardment or just whenever you look at sun, remember the nuclear reaction is taking place there, and the nuclear reactions do not follow law of conservation of mass. Coming to the next law, I think we can just leave the questions because you simply have to, I believe that you know that for proving that this particular thing follows the law of conservation of mass or not, that what we have to simply do, we have to simply find the total mass of reactant and it must be equal to products. Talking about the law of definite proportion, we simply understand or we simply say that in law of definite proportion, that the source of a compound can be different. Like water sitting in Delhi, I'm getting it from river Yamuna. You might be getting it from maybe that sea, since Chennai is surrounded by a lot of sea water, so you might be removing salt from it and then using it as a drinking water, right? But both of us are drinking a molecule named as H2O. It rained heavily here. What I got, it was again H2O. If I put it in freezer, it will again be H2O. So this is the law of definite proportion, that sources can be different, right? So here we say that carbon dioxide, just a representation. How can you get carbon dioxide? The purpose of putting that particular example is that you must be familiar with the reactions now, right? So if I go back, I will tell you that if you heat carbon and oxygen in air, carbon dioxide is formed. During the fire, lot of carbon dioxide is formed, right? Many polluting gases are removed from the chimneys of a factory. They contain large amount of carbon dioxide. The chemical reaction, the first one, is an example of exothermic or endothermic reaction. Can anybody quickly tell me? This you should have done in class 10th.
Endothermic reaction, ma'am.
Correct. So when you heat calcium carbonate, you get carbon dioxide. If you heat sodium bicarbonate, you get carbon dioxide. So, or I will say that when you open any soft drink bottle, again you get the bubbles of or the fizz of carbon dioxide. So getting it from any place, it will be giving you the formula. The formula of it will always be CO2, and the ratio of carbon to oxygen will always be 3:8. I still say that start writing the reactions as many times as you say. Whenever you find, like I just telling you one fact. My father was working in HCL, and as a chemistry student, I always struggle to write his company's name as capital H, capital C, followed by capital L. I always is in a habit of writing capital H, capital C, small l. So that should be, if you ask me to write iron, I'll write Fe, not iron. So you should start building up that practice, that you have to write the name, not write the names of the substances. You should be writing to the symbols and the molecular formulas of the compounds. So I think you can solve the question. Would you want to solve a question, or should I proceed?
You can presume, ma'am.
Okay. Similarly, we have law of multiple proportion. When an element combines with one another element and then it produces many compounds, like carbon reacts with oxygen to produce two compounds, carbon monoxide and carbon dioxide, right? Or hydrogen reacts with oxygen to produce two compounds. Can you name them? I can just hear some murmur of the conversation going on between the students, not anything else.
Ma'am, water and hydrogen peroxide.
Very correct. Water and hydrogen peroxide. Good. So oxygen is to oxygen. They are reacting with the fixed quantities of hydrogen. Two atoms, two atoms. The ratio of oxygen is to oxygen in water and O2 is 1:2, right? So sulfur reacts to form carbon monoxide, sorry, SO2 and SO3. Now, Gay-Lussac's law of combining volume, is the law clear to all of you?
Yes, ma'am, it's clear. Ma'am.
Okay, okay. Then quickly answer this question. I just put this question especially for this class. Choose the reaction or reactions which will follow Gay-Lussac's law. And I have deliberately not put the physical states in the question. And I again say, please read the question carefully. One by one, please have a unanimous answer. Even if you have a different answer, speak one by one.
From third reaction.
Third reaction will follow. Rest of them, none of them is supposed to follow it.
And some other student is going to.
So someone said third. I'm looking for more answers.
You said that.
Please don't fight. It looks as if you people are fighting there. Don't fight among yourselves. Have all the students solved the question? Okay. Tell me about the first. Okay, tell me the first reaction. Hydrogen and bromine reacting to give us HBr. Will it follow the Gay-Lussac's law or not? And with the reason, anyone? I'm waiting the class to answer my question. Yeah.
No, it is 1 and 4.
1 and 4 will follow Gay-Lussac. Everyone says.
One, four, five.
1, 4, 5. Okay. Somebody said 3 only. The other one is saying 1, 4, 5. Any other answer?
Ma'am, it's 1 and 5.
Okay, 1 and 5. Any other answer? Or should I start giving you the answers? Or tell you how to find the answer? See, the trick here is that you have to know the physical states of the compounds. Or sorry, the elements and compounds both. Now we all know if I take them one by one, the physical state of hydrogen is, it is a gas at room temperature, right? Now, what about bromine? Is it a liquid or a gas at room temperature? And before I ask that question, Gay-Lussac's law of combining volume applies to the reactions which have only gaseous reactants and gaseous products. Is that clear to the entire class? What is bromine at room temperature? We studied a chapter named as non-metals and metals in class 10th. What is bromine taught to us? Quickly.
Bromine room temperature is liquid.
Bromine is a liquid. Hydrogen is a gas. NHBr is a gas at room temperature. So why one will be following the Gay-Lussac's law? It will not. It will not follow. Isn't it? Is it clear? See, I deliberately put those substances or such reactions in which you are sure of physical state of all of them, right? Except maybe for the last one. So that means it is not the answer. Second will obviously not be the answer because sodium is solid at room temperature. The third one, we know that nitrogen is gas, hydrogen is gas at room temperature. Ammonia, if you do not know, whenever you pass by a public urinal, what happens? You get a very strong foul smell coming from there. This smell is of ammonia. I put ammonia because you must have, I'm not too sure because of the frequent changes in the syllabus of class 10th rather. So there you are told that urinary systems is told, uricotelic, all those things are told. So I thought you may be knowing ammonia, but ammonia is the third one is the correct answer, that N2 is a gas, hydrogen is a gas, ammonia is a gas. Now, talking about the fourth one, what is the physical state of HCl? Any idea?
Liquid, ma'am.
No. There are two things. One is HCl gas and HCl aqueous. This HCl aqueous is called as hydrochloric acid. That is, whenever you react, hydrogen is a gas, chlorine is a yellow-brown colored gas at room temperature. If you don't know, I am telling you, right? So, yellow-green colored gas rather. So H2 and Cl2 react to produce HCl in gaseous state, right? It might be slightly tougher, or it was deliberately put to make you understand what HCl you see in the laboratory, or you are having an image in your mind, is not produced by the chemical reaction. While collecting it, it is prepared by reacting sodium and HCl or any other substance. HCl gas is produced, and this gas is passed into water, right? Or it is collected over water. So should the fourth be the correct answer or not? Tell me, HCl is a gas.
Correct one.
Yeah. So therefore, the fourth one is the correct answer. Talking about the fifth one, sulfur is solid at room temperature. Probably you may not be knowing about it, but sulfur has a medicinal value, which is part of your syllabus of class 10 non-metals and metals, where the teacher must have taught you the uses. Solid sulfur is used in ointment, and the deposits of sulfur are present in most of the part of the northern India. There is a place called as Dehradun, and there you can see these sulfur rocks are there. And since it is an antiseptic, it is used for curing the ailment of skin. So it is found there. H2 is a gas at room temperature. If you have started your practicals in class 11th, salt analysis, there you will be using H2S. Is it clear now?
Yes, ma'am.
So that means fifth will also not be the correct answer. We will have 3 and 4 as the correct answer. So from this class or till this point, I think I have tried to make a mark on you in the sense that you must pay details. You may pay attention to the details around you. Look for the things, understand their physical nature, understand their chemical properties. Everything cannot be just crammed like this, right? So whosoever has to score good marks in chemistry, please be looking for the books, looking your surroundings. Now, can anybody tell me? Let's end the class with an interesting question. Sodium chloride is a common salt which is very frequently used by us, right? Have you seen it a sort of wherever you have put the sodium chloride, during the rainy season, it becomes a syrup type of a thing. Have you noticed it?
Yes, ma'am.
Why?
Because it has H2O molecules inside it.
H2O molecules are always there, bache. They are there in the atmosphere. In the room where you and I are sitting has water molecules there. And how do I know about it? That if I take out don't go by my drawing. If I take out the bottle from fridge, what happens? You can see the droplets of water here. From where they have come? They were there in the refrigerator. They were there in the atmosphere. When they come, you take them to the room now. Temperature is higher. So what happens? The water molecules can, from the vapor state, they become liquid when they come in the contact of the liquid surface at a lower temperature. I think you have been taught about this phenomenon in class 10. Condensation.
Yes, ma'am.
Okay. So water was already there. So what is happening in this case? Sodium chloride will not absorb water. Sodium chloride, which has the impurity of I will tell you magnesium chloride. It is magnesium chloride which most of the time absorbs water and therefore it becomes a sort of a liquid. We say it is hygroscopic in nature, right? Is it clear to all of you? Can somebody summarize what we have done today? Since I cannot hear anyone, any noise from the classroom, I will say that we have tried to cover. Yeah,
Today we taught laws of chemical combination.
we talked about laws of chemical combination. How many of you are knowing the differences between Dalton's atomic theory and modern atomic theory?
Ma'am, can you repeat the question?
See on the screen, you can see I have written Dalton's atomic theory. Are you clear
Yes.
about it? Are you
Yes,
clear
ma'am.
about this? Okay.
Yes, ma'am.
How it is different from modern atomic theory?
Dalton said that atoms cannot be further divisible, but it has subparticles, so it is divisible. It is different from them.
See, Dalton's atomic theory, the homework for all of you is read Dalton's atomic theory from your class 10th book, right? There must be 4, 5 or 6 points in that. And write the, or rather make a column, something like this. In one column, put Dalton's theory, and in another, write the corresponding statement for modern atomic theory. Right? Is it clear now?
Okay, ma'am.
So we'll start the class from here. If you have done it correctly, as per the chemistry books, chemistry rules, we'll proceed further. We will definitely be talking about the mole concept, molarity, molality, normality, formality, whatever is there, right? You have normality and formality also, but the main focus has to be on molarity and molality, right? So I believe that you have learned something new or a different perspective to the section which you have already covered, right? Do you agree with me or not?
Yes, ma'am.
Okay, so see you in the next class soon. So till then, happy studying.